Hi guys, welcome to the part 4 of handling netCDF files using Python tutorial series. Now in this tutorial, I'm going to show you how to plot the data in your netCDF file into a map. So if you're just joining us for the first time, in the part 1, 2 and 3 I have already shown you how to download netCDF data for free. In this case, as an example, I have shown you how to download the netCDF files which contains data on rainfall and temperature, and also how to explore the netCDF files just to know what sort of variables are there and how to sort of extract the information of the netCDF files into a time series for a certain location of your choice. So if you would like to know what I just mentioned in very precise details, I would recommend you to check those 3 tutorials out. But if not, if you just want to know how to plot the netCDF files directly onto a map, you're still welcome to follow along. I'll still try to touch up on the things which we discussed in the previous tutorials in here as well, wherever it becomes relevant. Alright, so let's get started. Now, apart from installing the netCDF library, you will have to install one more library for the purposes of this tutorial, which is the Basemap Matplotlib toolkit. Because this toolkit actually offers a wide array of functionalities that we can use in order to set the background of our map. But installing this toolkit is actually, to be honest, can be a bit of a daunting task. I have tried using pip, I have also tried using conda, but unfortunately in both the cases I was actually not that successful. So I found another method to install this library directly using the WHL file, which I'm going to now share with you, which is this one. Now, this is sort of a repository maintained by the University of California, Irvine. So from here, what you can do is you can directly download the WHL file, do the installation manually. So let's see how we can do that. So the name of this toolkit is actually Basemap. So rather than trying to find the file like this, I can just do a simple Control F search and try to type Basemap, and that should give me the location over here. Alright, now it says that Basemap, a Matplotlib toolkit for plotting 2D data on maps based on geos. So the version of Python which I'm currently using is 3.7.4. So what we can do is over here we can find the version which is 3.7 Windows and 64-bit. So I'm actually going to download this one just by clicking over here, and we can save this file. I'm going to save it to the same location. I'm going to come to my C folder and I'm going to create a new folder over here called Basemap. And after that, I will take the downloaded WHL file from the downloads folder and put it somewhere over here. Alright, so we have the WHL file over here. Now let's see how we can install this using the Anaconda prompt. So I'm just going to go to my start menu and we can search for Anaconda prompt, right click and run it as the administrator. So I'm actually still going to use the pip to install this. Pip install, and now I'm going to take this path and copy it over here and set it right here. Put another backslash, and I would now require to copy the name of this basemap file including the WHL extension. So you copy the whole thing and you can paste it over here. Now let's hit enter, and as you can see, now it has started the installation already. Alright, now it says that successfully installed Basemap 1.2.1. so that's how easy it is actually to install this using the WHL file manually. Alright, so now since that's out of the way, we can get started with the actual coding. So for this I'm actually going to import 4 libraries. I'm going to import before that, maybe let's go ahead and save our file. So I'm going to navigate to the place where I would like to actually save my file. Alright, displaying the temperature data in a map. Now I can go to the file explorer over here. You can see that I have still those netCDF files which contains the average temperature information for years 1961 up to 1965. So I'm just going to create the new file somewhere over here, and I'm going to name it as displaying netCDF data in a map. Alright, so now let's go ahead and get started by importing the required libraries for this task. So first of all, as you might know, we definitely going to require the netCDF library, so I'm going to import that. Then we will also need the NumPy library. Finally, we are going to import the Matplotlib library. As PLT, and followed by the Basemap toolkit, which we just installed. So that one we can import by from mpl toolkits.basemap import basemap, and this B should be a capital B. Alright, so first let's go ahead and run this one, and just to see whether we configured all the libraries without any issue or not. Alright, now you can see that we got no errors, so everything seems to be fine. Now I'm actually going to read in one of these netCDF files. Now mind you, I got a few comments after the previous tutorial asking how to sort of merge the data from each of these files all into one. So this part actually will be covered in the next tutorial, but for the purposes of this tutorial, I'll only maybe pick one of the years just to show you how to sort of project the data into a map now rather than mixing up everything. So for this tutorial, let's pick maybe 1962. So I can read the file directly using the netCDF library. I'm going to create a variable called data. That's going to be equal to dataset, which is what you imported over here. Now we can give the path to the location where you keep your netCDF files. So this one, I'm going to copy this, followed by the file name over here. Alright, now we can hit run. And if I type data over here, you can see that it already imported the data for me. Save the latitude, longitude, time and t-average information into separate variables. Now recalling back from the previous tutorial, if you would like to know what are the variables inside this netCDF file, you can just data.variables. And over here you can see, or you can directly access the .keys. Now this one actually gives you what sort of variables that we have in the netCDF file. So you see that we have the longitude, latitude, time, t-average and rstn. So for this tutorial I would only be focusing on the first four variables, the longitude, latitude, time and the t-average. So let's go ahead and create separate variables for each. So I'm going to create a variable called lats, and that's going to be equal to data.variables. And out of the variables, now I'm actually going to specifically select the latitude, and by putting a colon over here, I'm actually directly calling all the data that's sort of stored in this latitude variable. So if you would like to see that, maybe if I only put data.variables lat, you can see that it actually gives me the information such as the long name, which is latitude, and the current shape, also the units, degrees north. But if you would like to access all the data, you can actually just add this colon inside the square brackets, and it will actually give you the array of data. Alright. So similarly, I'm actually going to also save this information of longitude. variables. Now over here, the real name of the longitude variable is actually lon, which comes from which comes from here. And over there, I'm also going to save all the information. Next, I would also like to have a look at the time. So time equals data dot variables. Yeah, as you might guess, this should be time. And all the information. And finally, the TAVE, which is the T average. That's going to be data variables TAVE. This name is supposed to be the same as the original name of the variable and all the data. Alright. Now I can run this one. And if you go to the variables explorer, now you can see that we have 4 different variables already created for each of these. Alright. Now I'm going to create a new variable called MP, basically representing the map. And this one is going to be equal to basemap. Alright. So now when we are using the basemap, we can specify a certain number of parameters, like which projection that we want to use and what is the area of the world that you're actually focusing on, because this is, as you can read over here, it's just a base map. So it's actually setting the platform for you to sort of plot all the data that you might have on top of that. So you have to first get your base correct, isn't it? So we have a certain number of parameters that you can specify over here. For example, you can specify the projection to be equal to MERC, which stands for Mercator projection. Also, you can specify a value called LLCRNR So even though it might be a bit confusing when I say it like that, this one refers to the lower left corner longitude value. Alright, so there's another parameter that you can specify, the lower left corner of the latitude. Alright, now you can guess, I think the next parameter that we might need is the upper right corner of the longitude and the upper right corner of the latitude, because once the program has those 2 points, which has the latitude and the longitude, it can create the boundary without any issue. That one would be URCRNR, upper right corner, longitude, and URCRNR, latitude. Alright, and finally you can also specify the resolution. This one I will put as I. So you actually have to specify these values in let's say decimal degrees. So how do you exactly know? Now I'll actually give you a quick example. If you are using a software like Google Earth, you can actually just simply open that. Alright, now if you are focusing on a country, let's say in Asia, something like, let's say for example, you're focusing on Malaysia. So the Peninsula Malaysia, which is this part. So if you would actually like to draw a box covering this country itself, and if you would like to know the boundaries, one thing you can do is actually you can go to this add place mark, and you can add a place mark over here. Ask the program to show the units in decimal degrees, just to be coherent with the units of the netCDF file. So after that, you can again create a placemaker over here, and when you move it to maybe somewhere over here, you can now see what is the latitude and the longitude. So this is the latitude of the lower left corner. So I'm just going to copy this one directly from here, and latitude, which is this. Similarly, this is the longitude. And I'm just going to move this placemaker to somewhere over here, which I can assume to be the upper right corner. And again, I'm going to copy the latitudes and the longitudes in a similar way. This one was latitude. And this is the longitude. Alright, so that should be it. So now we can run this. Oh yes, now we have a invalid syntax error because after each entry you actually have to specify a comma over here, which I missed. Alright, now it should be fine. Now let's run this again. Now you can see over here that it's running and we did not get any errors. Alright, so once you set the point to your preferred location, which would actually represent the lower left corner of our hypothetical boundary, you can get the latitude and the longitude information over here. But now you can see that actually the information is in degrees, minutes and seconds. So let's go back to our Python script, and I'm going to have a quick look again on one of these variables where it shows the latitude or the longitude information. And over here it says actually in the units are in degrees. Now here the degrees actually refer to the decimal degrees. So instead of getting the units in degrees, minutes and seconds, I'm actually going to change this by going to Tools, Options. So now I'm going to create a mesh grid using the latitude and the longitude information that we saved over here. So for that we can actually use the NumPy library. So what we can do is we can create maybe another variable called lat that's going to be equal to np.meshGrid, and that will be created based on the longitude values that we saved over here and the latitude values that we saved over here. And then we can specify our XY coordinates as MP. That's the base map that we specified over here. Now in the base map, I'm actually going to pass these two arguments of longitude and latitude over here. Alright, now let's do some work on the color schemes. So I'm going to create another variable called C scheme, basically for specifying the color scheme. And now I'm going to actually use the basemap.pcolor. Over here we specify the same x and y that we define over here. So that's going to be x, y. And as the third variable, I'm actually going to use numpy.squeeze for the t-average, which is this one. Now if you recall again some information about the t-average, maybe I can directly copy it from here. It shows the long name is the daily mean temperature analysis interpolated onto 0.25 degree grids, and this is the current shape. This 365, 280, T360 is basically referring to the time, latitude and longitude. So over here, let's say that we have the time starting from 0 up to 364 because the starting index is 0. We have to specify 3 variables over here. So the first one is going to be the time, and we separate it by a comma. The second one is actually going to be the latitude and the longitude. So for the latitude and the longitude, I'm actually going to use all the values. So that's why I put that colon over here. So for latitude and longitude. But for time, let's say if I only want to see the temperature of the day number 0, so I can actually put it over here as 0. But if you want to see the temperature of, let's say, day number 165, you can even set it over here like that. So just to get started, I will actually put the temperature as 0. Alright, sorry, the time as 0, which actually means the first day of 1962, because here we read the data for 1962. So that's actually 1st of January of 1962. Alright, and over here we can also specify the color map. That's the C map. So the type of color map, I'm actually going to specify it as jet. So if you care to go through the documentation of Matplotlib, it actually explains where these keywords come from. For example, over here you can see that we have different types of names for different color schemes. If you scroll down over here, you will find the one that I just specified, which is jet over here, which actually ranges from blue to red. So if you would like to go with rainbow, that's possible. Even with another color scheme, that's also possible. So I'll put the link for this down in the description below as well. Alright, so we can keep it like that. Yeah, over here actually we have to specify the name of the variable, which is taverage, because this is the variable for which we're actually trying to access the data. Alright, once you're done with that, you can specify, you can use the Basemap toolkit actually to draw the coast lines as well. So how we can do that is by specifying MP, because this is our base map over here. Because this is our base map specification over here. MP dot draw coast lines, and that should draw the coast lines for you. Even you can draw the states. MP draw states, and finally I'm also going to draw the countries. Alright, now we have almost come to the final part of the tutorial. Now we are going to specify a title for our plot. So that we can do by simply typing plt.title. Now this plt is directly coming from the Matplotlib library, which we imported at the beginning of the tutorial. And as the title, I'm going to specify average temperature on 1962, 1st of January 1962. Alright, so finally we can go ahead and type plt.show, because that will show the figure when we run the command. Alright, now you can go ahead and run the script directly by hitting F5, or either you can click over here and you can see that it's still running over here. And once it's done, you can see that based on the lower left corner coordinates and the upper right corner coordinates which I specified, you can see that it has actually extracted me the information of around Malaysia like that. But there are some issues with this figure, because first of all, there is no color, there's no scale that we can see which we can use to interpret the different colors. So I'm just going to close this for the time being, and I'm going to create a color bar over here, specifying a variable C bar. That's going to be equal to mp dot color bar, and that color bar we are going to apply to the color scheme over here. And we also can specify the location of the color bar. Now we can set it to be on the right side of the map, which I think would be a good location to place the color bar. And I'm also going to specify another argument pad equals to about 10%. Alright, now we can go ahead and run this one and see what happens. Alright, now you can see actually the color variation is quite clear now. You can see these values are referring to mostly ranging from upper 20s to 30s, so that's why the whole thing looks red. Now just before I conclude the tutorial, I would actually also like to see a wide range of countries. So instead of using my lower left corner and the upper right corner just to box one country, I'm actually going to expand the boundaries. Maybe I will use a boundary which is somewhere over here as the lower left corner, and a boundary which is somewhere over here as the upper right corner, so that I can actually get a very clear picture of the color variation across different countries, especially in this Monsoon Asia region. So I have already acquired the coordinates for that. So I'm just going to directly type it over here. Over here it's 42.8. Again, if you would like to do this by yourself, you're very welcome to do so. You can just go back to Google Earth and move your location around, and based on that you can actually obtain your lower left and the upper right corner coordinates. This one I'm going to specify as -2, and the upper right corner, it's going to be 105.37, and the upper right corner lat is going to be 38.78. Alright, now I'll run this again. Now that's a much better picture, isn't it? Which actually shows the color variation across different countries in Asia. As you can see over here, around China, it's quite colder, which might be in probably about -10 to -20. Also, there are some locations I see actually which is quite blue, which might also reach to -25. Over here, as we come to the southern part, you can see the temperature is actually increasing, even for the Southeast Asian region countries. So I think that concludes the tutorial for today. I guess you learned something new. You learned how to plot your netCDF data into a map like this and visualize it like this. So you can actually play around with the different components of this Basemap toolkit, and also with the different color schemes which gets offered with this extensive Matplotlib library to make your map look much nicer. But for this tutorial, the main aim was for you to actually give you the context of how to sort of transfer your information into a map when you have this gridded information, how to sort of create the base map first and then project your data on top of that base map so that it looks like this. Alright, so that's about it for this tutorial. Now next tutorial, I'm actually going to show you a cool trick how to create a time lapse. Let's say in this case we have the data starting from 1962, 1st of January up to 31st of December 1962. This is the map which is corresponding to that. In the next tutorial, I will show you how to acquire all the maps, let's say in a JPEG format, and how to record all the maps into one continuous sort of an animation which shows you time starting from the first day all the way up to the 365th day. And through the variation of the colors, you can actually see the temperature variation throughout the months of the different months and weeks of the different year. So that's going to be explained in the next tutorial. So if you like this tutorial, please hit the like button, and if you did really like it, you can actually consider subscribing as well. And I'll see you in the next one.